Popular mechanics. Scientists say there's no difference between the past and the future. Mathematically speaking, at least. According to new research, physics does not distinguish between the past and future. Researchers found that because many equations allow for time reversal, flipping those equations will not change anything, even though something that happens in reality doesn't just undo itself. Reversing time had no effect on hypothetical particles, even though we can't exactly pull it back to the future yet. Related story. A student just proved time travel is possible. The arrow of time describes the clear asymmetry that makes the past intrinsically different from the future. The research team wrote in a study recently published in Scientific Reports. And yet, the fundamental laws of physics in both the classical and quantum realms do not manifest any intrinsic arrow of time. Newton's laws of motion allow for time reversal. So does Schrödinger's equation, which predicts the probability of something happening in the future, such as whether that cat is dead or alive. The concept of past and future being physically symmetrical may be difficult to grasp in a world where things that have already happened cannot undo themselves. An expensive vase that pops and shatters is not going to magically put itself back together and end up back on the table where it belongs. However, when you really get down to the crux of equations that describe how our world works, they could face either way. You wouldn't be able to tell the future from the past, and vice versa. This is where Markovian dynamics come in. In a Markov chain, everything goes one way. For example, the quantum state of a physical system describes everything known about it and determines the transition to its next quantum state. A Markov chain like that can keep going infinitely. The team behind the new time discovery applied this logic to a hypothetical cloud of superheated particles that expands with the universe, and through a series of mathematical equations, they found out that time reversal had no effect on the particles transitioning between quantum states. And it's not just quantum states. We have a linear perception of time. Whatever will happen later is in the future. What is now occurring is in the present. Something that occurred and is over is in the past. But scientists still have some questions. For example, do the laws of physics also demand a past, present, and future? And was there ever a beginning of time? Recently, a team of experts from the University of Surrey set out to answer those exact questions. While the beginning of time, if it exists, proved elusive, the researchers did find that physics does not distinguish between a forward and backward temporal trajectory. Physically speaking, it is just as likely for time to move backwards as it is for it to move forwards. The motion of planets around the sun, as much as the oscillations of a pendulum, are phenomena that do not distinguish the past from the future, the Surrey team said in the same study. A movie of these processes, played backwards, would still represent a perfectly legitimate physical phenomenon. Of course, this leads to another unanswered question. If quantum physics doesn't care what direction time is moving in, why does history exist at all? It might have something to do with the expansion of the universe. The Big Bang theory assumes that an extremely hot and dense mass of particles once began to expand further and further out into the void. And while that expansion has continued, the particles have significantly cooled down. But they aren't reverting back to the temperatures they were at almost 14 billion years ago. Cooling was what helped particles condense into stars, planets, and other objects in space. Reversing that would break everything down into particles again. There might still be a way to equalize past and future, even after the Big Bang. Another controversial study hypothesizes that time symmetry might be possible if, at the moment of the explosion, two parallel universes were created rather than just one. We only see a past and a future because we are living in one half of a continuous line of time. Whether we actually live in a parallel universe has yet to be determined. And for now, at least, time reversal is only possible in theory. So hold on to your watch.